We had just one question for homework last night. It was based on the acceleration of gravity and those group B equations that we apply to gravitational acceleration problems. Listen, these problems that we see involving gravity are the same as any other acceleration problem, except we got one more given. That given is the acceleration of gravity, negative 9.81. Real quickly, can anybody explain to me why the acceleration of gravity is always negative 9.81 in the absence of air resistance or something else, okay, any other forces? Why is it negative whether it goes up or goes down? Cody? Okay, so it's negative when it's going up because it's slowing down. Okay, anybody tell me why it's negative when it's going down? Yep. Good. It's speeding up, but it's going down. So either one of those makes it a negative value. Gravity is a negative number, and it doesn't matter whether you're going up or down. That's a good thing, because since it's the same value of acceleration, whether you're going up or down, it leaves open the potential to analyze a problem involving an object going up, then going down, treating it as one problem. It's only one thing happening, right? You think like, oh, it's going up and it's going down, but the acceleration is the same the whole time. We don't have to break it up into separate problems normally. All right, we had one question on page 60. Let's take a look at that. And then we'll move on to our next stuff here. It says, a pebble falls from a ledge that's 20 meters high. Find the velocity with which the pebble hits the ground, and find the time that it takes to hit the ground. Anthony, what do we know the velocity with which it hits the ground is not? We know that it's not zero, right? After it hits the ground, the velocity is zero. But as it hits the ground, the velocity is something. Okay? It's moving when it hits the ground. And if we look at the collision with the ground, well then after that collision takes place, the velocity would be zero. But that's a different problem. Okay, if we're analyzing the trip downward of the pebble, then the final velocity is not zero. If we're analyzing the collision of the pebble with the ground, then the final velocity is zero. But that's two separate problems. All right, so what do we got here? Something's 20 meters. What is that? Should make it 20.0 technically, I guess. What is that? Yeah, that's displacement. I'm going to make that a negative value, though. How come? Good, it's downwards. If we're going to make gravity negative 9.81, then that displacement has to be negative 20 meters. Boy, that's all we got, I think, isn't it? Anything else? Anything else if I read between the lines here, Thodas? Good. Acceleration is negative 9.81 meters per second squared. Although it's speeding up in the negative direction. Good. Good. How do you know the initial velocity is 0 meters per second? Yeah, if it falls from a ledge that's 20 meters high, then if it's dropped from a height that's 20 meters high, then we're going to make it 0 meters per second for the initial velocity. If it was thrown downwards, then the initial velocity would be whatever the speed was when it left your hand. Okay, that's not the case here. We're looking for the velocity with which it hits the ground, and we're also looking for the time that it takes to fall to the ground. What do you want to try first? Guys, listen, we're looking for final velocity in question A. Is there any reason why we can't solve for time first? Not at all. It doesn't matter what order you solve for. Thodas, what's your idea there? Okay, I'm going to write that down. Whether we end up using it or not, or whether it ends up getting an answer or not, I don't really care right now. I'm going to write it down because it's a valid equation. Okay, if that thought came to your mind, that's a correct thought. Write it down. See if you can make it work. If you can't, what do? Try another one, right? No big deal. What do we got? We're looking for VF. We got VI, A, and D. That's going to work for us, right? VF becomes the square root of VI squared plus 2AD, but VI is 0. Becomes square root of 2 times negative 9.81 times negative 20.0. We do the math there, and should, I presume, work out to be 19.8 meters per second. Okay, we got a bit of a problem here. They tell me the answer is 19.8 downwards. I didn't get a negative for this. Why didn't I get a negative? Does that mean that the answer that I got is 19.8 upwards? Yep. Can we? Good. I didn't solve for velocity, I solved for speed. But that's okay. Right? We need the direction technically because we're asked for velocity. But if we need the direction and the object is falling, it doesn't take a rocket scientist, I think, to figure out which way the rock is moving as it's falling. Okay, it's falling downwards. So we can just tack on a downwards to the end of that, not because the equation tells us that, but because our brains tell us that, right? If it's falling, it must be moving downwards. B, the time that it takes to hit the ground. Any ideas for this one? By the way, that should be 3 significant figures, right? So we have it rounded, because this is 3, and 9.81 is 3. If I had something that was 2 digits, I would round that to 2 digits. Okay. Okay, that's a perfectly valid equation. It's going to work for us. Well, we're not really sure if it's going to work for us, but we know that it's a correct equation. So it's worth trying, and we'll see. We got D. VI is 0. Okay, that's good because that makes the math easier here too. A is negative 9.81, and T is unknown. Good, that's going to work for us. Yeah. A is equal to delta V over delta T? Absolutely, absolutely. Any of those 5 group B equations are valid here. And I think you're going to find that probably certainly more than this one works. Probably more than the 2 we just addressed, A is equal to delta V over delta T. Probably more than that would work. Okay, but this is the one that came up. And this is the one that Anthony mentioned, so that's the one we're going to go with, as long as we can make it work. Solving for T here. Solving for T. Let's get rid of the half and the A. How do you get rid of the half A? Divide it, good. So we're going to say delta D over 1/2 A. That equals T squared. But of course, now that we've got rid of the half A, we have to get rid of the square now, right? How do we do that? Good. It's kind of ugly looking here. Bucks. Nevertheless, that's the way it looks here. Let's plug in our numbers here. Delta D is negative 20.0 meters. Don't forget to plug in the negative value. Over 1/2 of negative 9.81. Don't forget to plug in the negative for that one either. All right, I'm going to do this one on the board here because some people, although they may have it rearranged correctly, some people will mess up on plugging this into their calculator. Everybody should take out the calculator right now and do this with me. I'm going to do what's inside the square root sign first. I'm not going to worry about square rooting it right away. I'm going to say negative 20 divided by, what do I want to put next? 0.5 times negative 9.81. Is that right? That's wrong. That's going to give us the wrong answer. How come? What does our calculator assume that we wanted to do when we do it this way? Yep, Miles? I'm sorry? No. Well, yeah, because 0.20 divided by 0.5 is double, I guess, yeah. But that's not the big thing, because in the end, we do want to do that. It's not the 0.5 that's the issue there. Yeah. Yeah, it's going to say negative 20 divided by 1/2, and then we're going to multiply that number by 9.81. That's not what we want to do. We want to multiply the 0.5 by 9.81 and keep that on the bottom. So we want to change that. Even though it doesn't say that right there, we want to put some brackets. We want to put some brackets here on the bottom, 0.5 times neg 9.81. That make sense? That's telling the calculator, do what's on the bottom, and then divide negative 20 by whatever was on the bottom. Press equals. It's not our answer, because we got to square root that. When we do, we should get 2.02. 3 digits again. We got 2.03. Interesting. Final answer is 3 digits. Why? Because, well, the displacement is 3 digits. The acceleration is 3 digits. And that's all the data that we used. Good?